Energy, entropy, and free energy. To understand how life works, we must understand the concepts of entropy and energy and how those relate to free energy. First, we'll use an example that's easy to see. Then, we'll apply that to chemistry. We learned earlier that energy is conserved. Also, it is often said that energy is the ability to do work. There's a flaw in this thinking. Consider the case of our rock on top of the cliff. Before it falls, its energy is in the form of potential energy. After it falls, its energy is in the form of dispersed heat. Does the energy stay constant? Does the ability to do work stay constant? Discuss. To drive a stake into the ground, you need to do work on it. Which approach would work best? Dropping a rock on the stake, or dropping a rock onto the ground next to the stake and then using the dispersed heat? If energy is the ability to do work, the answer should be that both approaches are equal. Are they? It's difficult to harness energy that's in the form of dispersed heat. It's not very efficient for doing work, but it's still energy. Energy is critical to understanding the world, but is insufficient. A key missing element is entropy. Entropy is a measure of the amount of energy which has been dispersed, so is not readily available to do work. Note that the energy is not destroyed or reduced, it is dispersed. Energy stays constant, but entropy increases with time. Energy disperses, spreads out over time, and becomes less useful for doing work. So the amount of energy available to do work declines with time. Can you use the concepts of energy and entropy to explain what happens when a rock falls off a cliff? Discuss. The rock is pushed off the edge of the cliff and lands on the ground. What happens to the energy? What happens to the entropy? Energy is conserved. It is the same before and after the rock falls and hits the ground. Entropy increases. The initial potential energy has been converted into heat, which is dispersed and less able to do work. After the rock has come to rest on the ground, explain, in terms of energy and entropy, whether the energy, now in the form of heat, could launch the rock to the top of the cliff or not. Why or why not? Discuss. Although total energy is conserved, much of that energy has become unavailable to do work. Entropy has increased. There is no longer enough useful energy to do the work of lifting the rock back to the top of the cliff. It would be impractical to use the dispersed heat to lift the rock. We refer to dispersed heat energy as being useless. Heat itself has uses. If you're cold, it is very useful. It is possible to build heat engines that are pretty efficient if they're designed to concentrate heat in a boiler before it disperses. But after heat becomes dispersed, it is, for all practical purposes, useless. We will use the terms dispersed heat and useless energy interchangeably, as they're mostly true. Within the universe, there is a constant amount of energy, a constantly increasing amount of useless energy, and a constantly decreasing amount of useful energy. Free energy is the amount of energy available to do work. Free energy equals total energy minus useless energy. The total amount of energy is conserved. Energy cannot be created or destroyed. However, the amount of useless energy always increases. Therefore, the amount of free energy always decreases. Let's start with 100 units of total energy, 10 units of useless energy, and 90 units of free energy. At a later time, the amount of useless energy increases to 20 units. How much free energy does the system have at that time? At the later time, when there are 20 units of useless energy, there would now be 80 units of free energy, and you can see there's still 100 units of total energy.